All right, so this is going to be chapter 2. It's going to be 2 short videos for this week. And so we'll start with the science and matter part of it. And then for the second one, we'll do energy and systems. So what we want to do is talk about how scientists look at nature. You know, a lot of science is done in labs. Nature is a little more difficult because you have so many variables out there. So this was a study that was actually done, talks about in your book, where you can see how if you let a river meander versus one that kind of is channeled, you can see all of this now is not getting the water. There's water, there's erosion. And so 2 very similar canyons with different issues. What we want to do is look at how scientists look at these questions. And it's really kind of called the scientific method, and you don't have to be a scientist to do it. We all do it. It's just a little more formalized. So some of the keys are on the side here, and I don't want you to memorize every step here in the picture. But reality is what we're doing is we start with observations. We notice things, we look at things, and what those do then is drive questions and develop hypotheses. And you probably have heard hypotheses as an educated guess. So this is, I'm looking at something or I'm hearing something, you know, it could be any of your senses. And I'm trying to make sense of what I'm hearing or seeing by what I already know. And then I start to ask questions, and those are what really the hypotheses are. And then we collect data. We take measurements. And then once we do that, we run the experiment, we're taking data, we're gonna do a mathematical approach. You analyze the data, and then you come up with some conclusions. And that's kind of, you know, what does that mean? And hopefully that actually leads to more questions. And so what we want to do is make sure that you know what science does. And actually science never proves anything. What we do is we eliminate possibilities. We eliminate possibilities. That's really what we are out to do. So the idea is we have five ideas and we eliminate 4. That leaves us with the 5th one. That does not necessarily mean it's right. But with it's kind of our best guess. So I want to make sure you understand this. Hypothesis, a theory, and a law, are they the same? And the answer is no. A hypothesis is an educated guess. It's, okay, we're looking at something. These are the possibilities with what I know that I think can happen. Are they true? Not necessarily. Theory, on the other hand, again, may not be true. But I want to make sure you understand, in the general population, hypotheses and theories are kind of almost interchangeable, and that is not the case. In science, they are 2 different things. Theory is a tested hypothesis. So we have tested it, and all the tests have confirmed that this is still a possibility. So a theory has a lot more weight behind it. Again, it could be wrong. You know, there are still ideas out there. We have a couple theories on how things work. And what you do then as a scientist is you try to design experiments. You come up with hypotheses that can eliminate one of the 2 theories. That really is kind of how science works. Then the last one is a law. And a law, again, science really doesn't prove anything, but a law is something that everybody knows, pretty much agrees is true. And the best example of that is gravity. Gravity exists. I can't see anybody saying it doesn't. And so we've all agreed upon that would be a law. And there's very few laws in biology, it turns out. And the laws we use often are borrowed from chemistry and physics. So one of the reasons I love biology is so many factors involved and so many unknowns. Lots and lots of interesting stuff out there. All right, and we want you to start critically thinking. You know, be skeptical of what you read or hear, especially for me. You know, who am I? I'm a guy getting paid to sit up here and film me talking crap. So always question, look for evidence. And then when you see evidence, my thing is, where did it come from? When I read an article, when I watch the news, when I read the paper, you got to remember who owns it, who's publishing this, who's putting this information out, who's speaking. Everybody has an agenda. And I think I've mentioned that earlier in the semester, but you really want to pay attention where that information is coming from. And the thing is, I told you, I love to argue. Always listen to the other side, you know, and maybe even take the other side in an argument. Not that you necessarily believe it, but argue the other side, because that will give you a better understanding where they're coming from. And always, you know, you are just like everybody else, have an agenda, whether you know it or not. So you always got to you know, think of, you know, where am I coming from? What am I? What is my background? How am I viewing this information? Because you know, we also see everything through these glasses of experience. This is our perception. It's kind of this window. All right, and now let's go into a little bit of the chemistry, and I don't want to do too much of this, so we're going to keep this really, really light. You know, molecules are two or more atoms. You know, things are made up of atoms and make up of elements. On the right, we have ions. It's a term that we've used and we're going to continue to use. And I want you to know an ion is just a group of atoms that actually has a charge on it, whether it's positive or negatively charged. Like sodium is Na plus is sodium, it's a positive charge. OH negative is a hydroxyl, it's a negatively charged. So just want to let you know those terms. And then in this course, you know, these are the ones that'll probably be mentioned at some point. And, you know, we've talked about chlorine already. It's a negative ion. I'm trying to go through here. You know, I see mercury on there. We've talked about that one. And nitrogen, phosphates, phosphorus. So you can see some of the stuff that's already up there that we have talked about. And I'm doing this just because I wanted to give you, now I'm not going to test you on this chart, so don't panic. But I just wanted there, and maybe you can use it as a reference as we go. All right, and then the laws of conservation of matter. The idea behind this is physical or chemical changes can take place, but there's no atoms are created or destroyed in the process. And so what they're trying to show you is this guy's holding two different chemicals in his hand. He mixes them together, bang, it explodes. Energy is given off probably in the form of heat, but reality is there is no change in matter. You can see that on the bottom. They weigh the same before and after. So that's important when we talk about things, and especially when we get into the next video, which talks about energy, because this also has a conservation of energy. So we'll talk about that a bit. And that is the end of the recording. So we will stop share and stop the recording.